my first talk will be on research's contributions to the selection of medically relevant risk alleles in clinical practice, right? So some of this will be review, and then we'll get specifically into single nucleotide polymorphisms and how they relate to our research. So, forgive me, I'm not used to the pointer. All right, our learning objectives. You guys have probably already seen these. We want to look at the key terms related to research, how is the research prepared. I'll do a little bit of history, the different styles of research, and then, most importantly, gain the ability to critically assess the research and apply it to relevant testing modalities. Because as you explore your options in the world of the different genetic tests, you'll see there's a huge variability from one company to another and what single nucleotide polymorphisms are looked at. So this is our effort to really explain how we should choose which SNPs are truly relevant, right? Then I want you to understand the clinical applications of the research and discover new research associated with popular single nucleotide polymorphisms. So what is research? Oh, I keep pressing the wrong button. What is research? The definitions are a little bit different, right? The Oxford Dictionary says it's the systemic investigation into the study of materials and sources in order to establish facts and reach new conclusions. But in a more scientific manner, you can see this multidisciplinary approach to assessing research practice and quality. They say the practice of working in a scientific manner is research. So research is what you practice, and the result of this work is science. Today, in medical research, we have the entire world sort of works under this Declaration of Helsinki that was first put out in the 60s, 70s. I think it was put out by the BMJ in the 60s, following the Nuremberg trials when all of that horrific research was conducted in Nazi Germany. And this has been modified over and over, but what it really tells us is that what our primary purpose of medical research is, and it maintains the ethics of it, what the purpose of this research actually should be, and that even the best proven interventions must be evaluated continually for the research for their safety, right? We can't just say something's safe and then over time say, okay, well, it's still safe, because as time goes by, we often find that medications that we might think were safe really do have some serious consequences down the line. And then just in terms of some fun history associated with research, the first research that we really have documented is in the book of Daniel in the Bible in 500 BC. And that was when the king of Babylon said, all of our people will eat meat and drink wine, right? He thought that that was going to be the most nutrient-dense diet. But a bunch of royals were really opposed, and he allowed them a 10-day trial of eating legumes and water. And at the end of this 10-day trial, who do you guys think was healthier? So he allowed them to continue to have their water and legumes, but he did still support the use of wine and meat as the main meals consumed by the rest of his country. And then, in the 1500s, the first research was done based with like a control group, because in warfare, in the 1500s, if someone in the military was injured by a gunshot, for example, they used boiling oil to treat that wound. And one of the surgeons was running out of oil, so he came up with a concoction of egg yolk, rose water, and turpentine. And he applied that to the people who didn't have access to the oil. And it talks about how he was stressed out and he was up all night worrying. And the people with the concoction of rose water and egg yolk and turpentine did significantly better than the people who got burning oil poured onto their wound, and he goes on to talk about how, he will never subject someone to such a horrible fate of having burning oil poured on their wound when something so much less painful has much better results. And then I'm sure everybody knows in the 1700s the scurvy association with citrus. And what's interesting is that although that was 1747, that was James Lind discovered that in 1747, it took 50 years before they started forcing lime juice to be on ships with these seafaring folks because of financial reasons, right? And we can all sort of look at today and how the financial aspect of things really motivates a lot of medicine. So I thought that was really interesting. And then in the 1800s, placebo was introduced. In 1943, we had our first double-blind controlled trial on penicillin for the common cold, and actually the outcome was not really that promising. Okay, so the forms of different research that we're going to talk about today. We've got case reports and series and surveillance studies. What I just did here. Okay, then we've got cross-sectional cohort and case control, clinical and quasi-experimental research, and then in our world of genetics, we really look at meta-analyses, reviews, and genome-wide associated studies a lot. And I know at continuing education, we really do hear a lot of clinical trials, because that's, as you know, if you have physicians presenting, that's what we see and that's what we can use. And I think it's some of the most interesting stuff out there. But in a world of reporting genetics, we really need to make sure that a wide range of populations have been tested before we apply that information. Descriptive research, so that would be the case reports, case series, and surveillance studies. I'm sure this is all repetitive for you, so we'll just do quickly. The case report's an examination of a single case having a different quality in society. A case series is going to be an examination of repetitive cases having common features, and then surveillance is results obtained from the databases that follow and record a health problem for a certain period of time. And then we jump into analytical scientific research, and this has a few different types, right? So there's observational or interventional, and then within those we have multiple types. Cohort studies, which are going to look at a group of people either in the past or from a period in time forward, and then there's ambidirectional. One of the real disadvantages is the length of time, obviously, to attain all of that information, but the information that is attained can be really advantageous. Case control studies we sort of already talked about. And then cross-sectional studies where they take a particular point in time in a population and look at information. And then with interventional research, we have quasi-experimental research where there's no randomization at all, and it can demonstrate the causality between an intervention and an outcome. Big ones would be like introducing hand sanitizer to a hospital before and after. How does that change the rate of disease and illness? And then clinical research trials, really commonly drug companies, sometimes supplement companies. You got to be really careful with these because of the funding behind them. It can really influence the outcome. And then in the world of research, you just do need to be aware of the pressure to publish in the world of research. So really taking into account what is the background motivation of these studies and who is publishing them. So our top three that we look at, meta-analyses, so that's when we're it's a study using statistical techniques to assess a bunch of different studies. So we can look at huge populations, and that really can benefit our ability to understand something like a single nucleotide polymorphism. And it's tricky, right? Because like we were talking about, there can be quite a bit of variability between ethnicities. So when you're looking at a meta-analysis study, you want to really pay attention to gender and the population and the culture being tested, but it is a real advantage because of the summary. The size of the population generally looked at. And then a systemic review usually incorporates part of a meta-analysis. This is going to be comprehensive search with the goal of reducing bias. And then the Cochrane collaboration is one of the many sources developed to promote and disseminate systemic reviews. So Cochrane, I'm sure you can look at their research online, and that's a good resource. And then gene-wide associated studies, or GWAS, that Dr. Kashi was talking about, those are aimed at detecting variants at genomic loci that are associated with phenotype. They're usually really large studies looking at a wide population, and that gives us a great deal of information. So when you're looking at research, you want to think about who's it written for, what's the audience, right? We've got governing bodies, we've got academics, we've got scientists, clinicians, and the mass market, right? Weight loss, Garcinia Cambogia, right? That was such a big one. Promoted all over the media, but to be honest, the research behind that, not that great. And then suggested methods of presenting your findings. This is just one, right? Do you want an article in a peer-reviewed journal, a popular science bestseller, engraved on the walls of a secret chamber, a transmission meme to alien masters, a Broadway musical whispered in the dark, or an internet meme involving cats? The meme's pretty fun, but I don't know that it's the most reliable. So what do we want to look for in our research? Quality, we want to assess the methods, the population. Looking for exclusions, this is a big one. What populations are cut out of the study versus included? Statistical significance, those p-values. Clinical significance, does this really apply? Is it going to make a difference in my treatment? Low incidence and versus high risk, right? So we often, in the world of single nucleotide polymorphisms, want to look at the ones that are more common. But if you have a very infrequent single nucleotide polymorphism, but the risk is very high, that's another one that we're going to pay attention to. And then when we're assessing research, we already talked about who's paying for this research, what's the underlying funding, and the conflict of interest. And you will always find that in a peer-reviewed journal, so it's easy enough to access that information. Sometimes you got to do some digging because there can be money behind something that seemingly doesn't have money. The mode of testing, so in vitro versus in vivo, do we want to really apply a murine study to a human population? Although it's really interesting and it might sort of push us in the direction, can we truly apply that to the human population? And then this more applies to medication and supplements, but dosing, especially like essential fatty acid testing. Fish oil, you'll see some studies that say it's not very effective, but then when you look at dosage, that could be a big factor. And then really peer-reviewed articles are going to be the most reliable. Is this validated by unrelated scientists? Is it published in a reputable journal? Because especially in the media, you'll see in the newspaper, these huge headlines about research studies, but if we don't look at where is this research coming from, what was the population, we can't really make an assessment as to whether we should be applying it to our patient base. So this is just a little bit of an infographic on research quality and how to assess it, right? That's more for you to enjoy on your own time. But then what are we looking for in the research? Again, so sort of redundant. What populations being studied? What's the gender? What's the race? Cultural background? Age range? Smokers or non-smokers? This can be a big one. And then overall environment. Is the study applicable to the general population based on the research population? So here you are in Portland. If you go out and you ask 10 Portlanders whether they like sushi or not, can you then take that information from that group and apply it to all of Portlanders? No, right? It's a really small group, so it's not fair. And it's not fair to apply a study like that to an entire population. One of the research scientists that I was looking into her work, she likes to use this example of whether you want to live in the Bronx or Queens. Right, so Queens, they say they had 1,700 deaths due to heart disease in 2002, whereas the Bronx had 882 deaths from heart disease in 2002. Well, it seems like Pelham Bay in the Bronx would be the better place to live. But the reality is the population is so different that it's much more risky to live in Queens. And then again, is it really that the heart disease has to do with the area you're living in, or is it just diet-based? I mean, we have to take into account all those other factors. So who's conducting the study? Is this a group of researchers based at a reputable university, an individual without clear affiliations, right? Those are things we want to avoid or dig deeper. Who's funding? We talked about this as well. Conflict of interest, and have the results been repeated? And then this was just fun too. Volunteers needed for a scientific study investigating whether people can distinguish between scientific studies and kidney harvesting scams. Avoid a kidney harvesting scam. Stay away from that. Distorted evidence. So we talked about this some more. There's a really fun TED Talk by this guy, Ben Kohlaker. And he goes into who's reporting this research, right? Dr. Oz, who I might trust a little bit more than Dr. Phil. And then, I know Dr. Oz pushed carcinate Cambodia, so it's questionable. You got to look at where this information is coming from. And then we talked about this already, in vitro versus in the actual person. Pharmaceuticals against placebo, and then more reliable evidence is going to come from trials that have controls and are blinded. Now we're going to get more into single nucleotide polymorphisms and genetics. What is important here? And this is an amazing field, you guys. We're really cutting edge here because the amount of growth is exponential, as you can see here. From 2000 until this is 2018. Look at where we are. 700 million studies, SNPs identified. And then with each SNP that's identified, it has to be validated. So it's a process, and we're just going to be moving forward at an incredibly rapid rate, hopefully. So who is validating these SNPs? We need to have PhD level scientists. These need to be validated to have at least a 20% prevalence in the population. We want it to be present in multiple racial and ethnic groups. And then also to have actionable benefit as opposed to, misleading us. The validations over time. So this is as we're validating the SNPs, the amount of publications coming out. And this is only going up until 2011, but as you can tell, every year multiple studies are being put out there. And we're just really lucky because the potential behind this research is to really get a step ahead and look at our patient and hopefully be that, like Dr. Kashi's quote was saying, we want to be that best doctor. We want to prevent. We want to get to our patient before they're sick. And we've got so much potential with single nucleotide polymorphism, addressing mental health and cardiovascular cancer, autoimmune disease, diabetes, all of these illnesses that are becoming incredibly prominent in our patients. And, every day it's just unbelievable. So once you identify that risk, you can personalize the treatment because we can't just look at the SNP. I mean, clinical presentation is incredibly high priority, and we always want to keep that at the forefront of our mind. But using that single nucleotide polymorphism to personalize our treatment allows us to reduce or prevent potential disease and improve overall outcomes, right? Decrease healthcare costs too, we all want to go down. And this is like a little study checkoff list. So if you're trying to assess research that any company is putting out saying this is why we're doing what we're doing, this is my little checkoff list too. Okay, are they citing studies that actually relate to the RSID of the single nucleotide polymorphism? Because for any SNP, MAOA for example, we're going to have multiple research studies, multiple RSID numbers identifying the particular SNP, and the research is going to vary based on that RS identification number. So when you want to find the most up-to-date information on a single nucleotide polymorphism, there are a few places that you can start. SNPpedia is super easy. You hop on that website, you type in a a SNP name, and it gives you the basic information. And then you can't scroll down here, but if we were able to scroll down here, all the RSIDs are listed. And if you look at these RSIDs, you'll see some of them will have loads of research behind them, and others will have minimal research behind them. And when we look, this is a prime example of how MTHFR C677T as compared to MTHFR A1298C are going to have totally different research, and people will argue homocysteine levels are not going to be affected by A1298C, although in a clinical setting we might see that. The broad research has found that the C677T is the more significant marker in terms of hyperhomocysteinemia. So finding the most up-to-date information, you can also go to NCBI. This is one of my best friends. I am all on here all the time. If you go to ClinVar and you type in the gene you're interested in, then it's going to tell you, okay, it'll give you the variation and the association. So is this considered pathogenic? And many of the single nucleotide polymorphisms being tested out there don't have a pathogenic assessment. Now that doesn't mean they're not, but the research out there doesn't support it yet at this point. So we need to use caution when we are utilizing these SNPs to determine our patient's health. This is dbSNP where you can actually put in the RSID number. And when we were talking about wild type and looking at research, it gets very, very confusing when you're looking at the research studies because they report SNPs very differently depending on the study. It might be FF for fast and SS for slow versus the base pair change. And this is an example of MTHFR 81298C. A lot of people consider it 1286AC, right? And these are all different names, and you can scroll down. There are even more. So this is a nice resource when you are looking at the research. You can hop in here and go, what are they talking about? What is this? How do I apply it to what I know? When a SNP is reliable, it doesn't necessarily need to meet all this criteria, but some of the criteria that we look for is there a gene-wide associated study? Is there a meta-analysis? Has the gene been studied by more than one research group? More than two research groups, really, right? We want to see that it's not being pushed by one particular group because we want to see that multiple scientists have found it to be relevant. Is it replicated? Is there a large enough population being studied? I love so many studies on like 180 people, and that just isn't something we can apply to everybody. We need more when it comes to reporting scientific research and reporting your patients' results. So we want a variety of ethnicities, addressing conflicting research as well. And then, there needs to be a minor allele frequency of greater than 5. And one of the things here with the conflicting research is you've got to be so careful. You need to look at all of the research out there because you can have one study that says if there is an association and then a significantly larger study that's going to say there is no association at all. And you need to sit down, and this is why we're here for you, because we sit down and we look at these studies and we look at the actual science behind the study and the populations and who's financing them, and we decide, okay, is this relevant or not?
Could you get those last thing? Please.
Go back.
Yes.
Yes.
My question was, you mentioned these criteria to be important for the selection that you're looking at.
Yes.
But you're not using all these criteria to select this. Is that right?
Well, sometimes you can't meet all of them.
Okay,
and
but what is actually the algorithm? When you decide which SNP is important or not?
I wish I had it here to show you. It's multiple steps and it's multiple people, right? We have our PhDs, we have our doctors, and then we all...
Let me ask you another question. What is a must-have for that?
What's a must-have?
Must-have.
Well, the research needs to be supportive overall. We're not going to have a gene-wide associated study. Well, in terms of us being cutting edge. There's no way to have a gene-wide associated study for every single nucleotide polymorphism we're interested in at this point. So really, we want to make sure we have to have a meta-analysis. We pretty much only report if there are meta-analyses done. And then that the meta-analyses correlate with the smaller studies too and make the most sense. And then we do want to see, we always want more than 2 research groups. We always want to see replication. We always want the population to be over 500. So pretty much the only thing that we don't have to have every time is this gene-wide associated study. All this other criteria has to be met, and then we sit down in our little circle and we all have to agree on it, and that takes months. In
terms of ranking,
passionate.
the meta-analysis would be number 1.
Yes, that typically is the most important piece of information. I'm going to just speed through the rest of these since we're running out of time here, but this is just a study on SOD1, which is really an interesting SNP, but is it clinically relevant for humans at this time? Most of the research is on rats. That when there's no meta-analyses associated with anything of interest to us at this point, which is why we don't report on a SNP like that. And this is an example just of how CYP1B1, this shows an association with breast cancer in 975 subjects, but this large meta-analysis says no association. That doesn't mean this isn't true, it just means that we can't apply it to the entire population. This is essentially telling us the same thing. And then looking at studies, the headlines, right? So the study uncovers new gene variants that quietly affect cholesterol. But then when you look at the research study, it's not a very large or diverse population. So it's not fair for us to take that information and apply it to everyone. And then when we look at the research, don't forget, you got to look at the clinical perspective too, and the patient standing in front of you.